The General Electric Allison J33 was development of the General Electric J31, enlarged to produce significantly greater thrust, starting at 4,000 lbf, 18 kilonewtons, and ending at 4,600 lbf, 20 kilonewtons, with an additional low-altitude boost to 5,400 lbf, 24 kilonewtons, with water-alcohol injection. Development. The J33 was originally developed by General Electric as follow, onto their work with the designs of Frank Whittle during World War II. Their first engine was known as the General Electric I.A., but after major changes to adapt it to U.S. production and to increase thrust, it started limited production as the I-16 in 1942, the 16 referring to its 1,600 lbf, 7.1 kilonewton, thrust. Full production started as the J-31 when the United States Army Air Forces introduced common naming for all their engine projects. Along with the I-16, GE also started work on an enlarged version, known as the I-40. As the name implied, the engine was designed to provide 4,000 lbf, 18 kilonewtons. Apart from size, the main difference between I-16 and the I-40 was the combustion system. The I-16 had 10 reverse flow cans, whereas the I-40 had 14 straight-through combustors. The development cycle was remarkably rapid. Design work started in mid-1943 and the first prototype underwent static testing on 13 January 1944. Lockheed was in the midst of the XP-80 project at the time, originally intending to power their design with U.S.-produced version of the Halford H-1 of about 3,000 lbf, 13 kilonewtons. Production of the H-1 by Chalmers ran into delays, and since the I-40 would dramatically improve performance, plans were made to fit the prototypes with the I-40 instead. The I-40 became important to the USAAF's plans when the I-16 powered P-59 was skipped over in favor of the I-40 powered P-80 as the U.S.'s first production jet fighter. In 1945, the license to actually produce the engine was not given to General Electric, but to Allison instead. Allison, working largely from government-owned wartime factories, could produce the engine in quantity more quickly and cheaply. By the time the production lines were shut down, Allison had built over 600 J33s and General Electric another 300, mostly the early runs. In 1958, surplus J33s were used in jet donkeys pushing dead loads at 200 knots to test aircraft carrier arresting gear cables and tailhooks at Lakehurst. A model of the J-33 intended for civil use designated the Allison 400C4 in 1948 became the first U.S. gas turbine certificated for commercial transport use. Variants. Data from Aircraft Engines of the World 1953, Aircraft Engines of the World 1957, Aircraft Engines of the World 1953, J33A4 similar to 21 without water injection, J33A6 4600 lbf, 20 kilonewtons, United States Navy, USN J33A8 4600 lbf, 20 kilonewtons, USN J33A10 4600 lbf, 20 kilonewtons, USN, used as mixed propulsion engine system with PNWR 4360 on Martin P4M J33A14 short-life engine. Powering the Chance, Vought Regulus, 600 lbf, 46 kilonewtons, thrust. J33, A16 similar to the 16A, 850 lbf, 26.02 kN, J33, A16A powering the Grumman F9F, 400 lbf, 24.02 kN, thrust. J33, A17 similar to 21 without water injection, J33, A17A, J33, A18A short-life engine powering the Chance, Vought Regulus. J33, A20 J33, A21 500 lbf, 20.02 kN, thrust. J33, A22 powering the Lockheed T2V, one with bleed air for boundary, layer control. J33, A23 similar to 35, 600 lbf, 20.46 kilonewtons, thrust. J33, A24 100 lbf, 27, 13 kilonewtons, thrust, powers the Lockheed T-2V, J33A, 24A6, 100 lbf, 27, 13 kilonewtons, thrust, powers the Lockheed T-2V, J33A, 25 similar to 35 J33A, 27 United States Air Force, USAF, similar to the 16A, J33A, 29-8, 200 lbf, 36, 48 kilonewtons, heat thrust, J33A, 31 similar to 35 J33A, 33-6, 000 lbf, 26, 69 kilonewtons, heat thrust, J33A, 35-4, 600 lbf, 20, 46 kilonewtons, thrust 5, 400 lbf, 24, 02 kN, with water, alcohol injection, powers the Lockheed T-2V and Lockheed T-33, J33A, 37 short-life engine powering the Martin Matador, 4, 600 lbf, 20, 46 kilonewtons, thrust, Model 400, C4 company designation, 4. Commercial use, similar to J33A, 21, Model 400, C5 company designation of J33A, 23, Model 400, C13 company designation of the 35 Model 400, D9 company designation of the 33 applications Convair XF, 92 Lockheed P, 80 Shooting Star Lockheed T, 33 Shooting Star Lockheed F, 94 AF, 94B Starfire North American AJ Savage Martin P4M Mercator MGM, 1 Matador MGM, 13 Mace SSM, N, 8 Regulus Specifications, Allison J33, A, 35 Data from Jane's All the World's Aircraft 1955-56, Aircraft Engines of the World 1957 General Characteristics Type, Centrifugal Compressor Turbojet with Water Injection Length, 107 in 271, 8 cm diameter, 55 in 128, 3 cm, dry weight 820 pounds, 825, 5 kilograms, components compressor, single, stage double, sided centrifugal compressor combustors, 14 type stainless steel combustion chambers turbine, single, stage axial fuel type, JP4, kerosene, and F32, or 100/130ths gasoline oil system, wet sump, pressure spray at 42 psi, 289, 6 kilopascals, performance maximum thrust, 4, 600 lbf, 20, 461, 82 N, static dry at 11, 750 revolutions per minute at sea level for take, off thrust, static wet, 5, 400 lbf, 24, 02 kN, at 11, 750 revolutions per minute at sea level normal thrust. Static, 3, 900 lbf, 17, 35 kilonewtons, at 11, 000 rpm at sea level overall pressure ratio, 4, 1 air mass flow, 90 pounds per second, 2, 449, 40 kilograms per minute, at 11, 750 revolutions per minute turbine inlet temperature, TIT, 1, 116, 15 K, 1, 549, 40 degrees Fahrenheit, 843, 00 degree C, JPT, 958, 15 K, 1, 265, 00 degree F, 685, 00 degree C, specific fuel consumption, 1, 12 pounds, lbfh, 32 grams, kns. Thrust, to, weight ratio, 2, 53 See also related development General Electric J31 comparable engines de Havilland Ghost Rolls, Royce Derwent related lists List of aircraft engines references further reading Gunston. Bill 1989, World Encyclopedia of Aero Engines, 2nd ed., Cambridge, England. Patrick Stevens Limited, ISBN 9781852601638. K. Anthony L. 2007, Turbojet History and Development 19301960 Volume 2 USSR USA Japan France Canada Sweden Switzerland Italy and Hungary, 1st ed., Ramsbury The Crowood Press ISBN 9781861269393 Wilkinson Paul H. 1946, Aircraft Engines of the World 1946 London Sir Isaac Pitman and Sons pp 272-273 External links J33 on Ledecky Motoric, CS